Okay, so before I start, I want to say most of the code here isn't exactly rocket science. It's stuff that I had to figure out that goes a bit beyond what you'll find in the documentation. And I'm very, very skeptical of third-party packages, especially the likes of Martini and Nigiri and all of these other things. And so I tend to like to implement something first based on the standard library, get as far as I can, figure out what the problem is, and then go and figure out if somebody did a better job than I did. Most of the code here is extracted out of this product which we're building, which is Harrow. It's continuous integration, testing, deployment, monitoring, everything all in one. It comes out of my work on Capistrano, which some of you may have touched if you had a kind of unhappy former life as a Ruby developer. Try it, sign up. We're not alpha yet, but we should be until the end of the year. Anyone who signs up today goes to the top of the waiting list, so no pressure. Sweet, okay. This talk is kind of code heavy, you know, Go is not the shortest language in the world, so we have about 200 lines of code maybe to get through. If anyone wants to play along at home, it's here. The slides have been here for a couple of weeks already, and they'll stay there. Fortunately, it's a small room and the projector's pretty good, so I hope everyone can read the code. There's a lot of it, there's a ton of it, but I've highlighted the important bits, so don't worry about reading it. You don't want to read it anyway. So, yeah, transactions. Anyone never used a database transaction? I know there's some like mobile developers in the room, so that you know everybody's familiar with this stuff, right? Cool. Then you can ignore this slide in particular. Interesting thing, I had one slide previously when I gave this talk in Hamburg, like giving the classic example of a database transaction, you know, being a bank transfer. Somebody I'm friends with in Hamburg actually works in a bank, and so they don't use transactions at all. So it's funny that it's a counterexample.
Which bank?
No comment. Yes, this shouldn't be super surprising either. I mean, Go is a concurrent language. It runs your tests in parallel if you have Go max procs at a reasonable value. So, especially point 2 here is super important. That doesn't work too well with Rails and other frameworks. But in Go, we have the entire test suite for Harrow runs in about 800 milliseconds, which considering we're close to like 40,000 lines of Go isn't too bad. And we have 80% coverage. Databases. I was really surprised, really surprised to see a NoSQL database here because I'm kind of from the school that if it's not Postgres, it's not a database. And along the way, I found out this Foundation DB thing is actually pretty cool, but I'm kind of embarrassed to admit it. So here's what a transaction looks like. No surprises here, right? Anyone? No. Okay, we're fine. And this is what happens if we're failing. Again, we've all seen, maybe not exactly this way, Rails hides a lot of this from you, Go doesn't, it forces you to deal with all of this nastiness. Interestingly, I tried to do a Redis transaction, and I knew Redis supported this multi thing, but I thought it was mostly an optimization to avoid committing to Redis and optimizing the wire protocol, but turns out there's actually a reason to use transactions for like data consistency as well. So I was looking around trying to find a way to make a Redis transaction fail. I mean, Redis never fails, right? Turns out you actually can't increment a hash. So, true story. Actually funny, like I said, I had to research how to make a Redis transaction fail, and I eventually figured out how to make one fail, and now it seems like every time I touch Redis it's broken. Just be careful what you Google for. So, for the rest of this talk, I need you all to use your imaginations and assume that we're dealing in this kind of environment. We have a pretty standard table, primary key that's auto-increment, and a name field that's, you know, nothing crazy here at all, except you also need to remember throughout the rest of the slide, 456 is a product or a widget or something which really exists in the database. So we'll run along through this, and again, nothing crazy. If you're not using Postgres, you should be. The code, if anyone really feels like it. I know there's not too many laptops in the audience, so at least you're listening to me, that's nice. You'll find all the code here. There's two versions of the code, the kind of broken starting point, which is where the wall you'll run into if you're using kind of Go and you're following the tutorials and you build the wiki that's in the Go docs, and then you actually want to test it, you'll run into the same problems that I run through here. And the format of this talk is following the obvious path towards building an HTTP controller, failing really, really hard, and then refactoring it until it's testable. So keep that in mind, because there's a lot of error messages in here, and they're supposed to be there. It's not because I'm a terrible programmer. So, okay, first, before we go too far, anyone never seen Go code before? Sweet. So, this is the top half of the main package. I lied a bit because this is using the transaction, using the standard library, but this, sorry. It's because we needed a driver. Slightly interesting thing here as well is that the Go driver for Postgres defaults to trying to use SSL, which is a kind of a nice default, and you have to turn it off if you actually want to work locally. So a show of hands, everyone fine with this, yeah? Cool. Also, for the rest of the talk, just stop me. If anyone has questions, because it is pretty code heavy, just raise a hand or shout. So absolutely standard here. This is main. We're going to talk about the foo handler now, which is probably should be named widget handler, but sorry, deal with it. And this is the body. This is the main body of the thing that we're writing. I'm going to break this down into two pieces, which is the form validation at the top, which exists just to make a nice error message. Otherwise, if we pass something invalid into the query statement, we get an error from Postgres because it's, where you get a database error because the type gets cast a bit too late and it's not very nice. And then we have the pretty standard database stuff, which is, again, all of this error handling could be a bit better, but it's here because we're trying to stay as close to standard code you'll find in tutorials on the internet anyway. As I said, we're doing some validation pretty early to make sure that somebody has actually passed us a string. This is a bit interesting because I said in Hamburg that this particular bit of code was designed to stop the database panicking. And it turns out that if we do the cast, it's about 10 times faster than if we wait for the database driver to do the cast. And I don't really know why. Maybe they're doing a type switch for every possible type if it's not the one they expect. I don't know. But I tried looking into it with one of the guys from Hamburg, and we didn't come up with anything. And in the end, the difference of a factor of 10 in an int cast was pretty small, so it probably doesn't matter, but at least this way we get a nice error message. And the rest of it, again, has anyone not used SQL in Go before? Okay, so we're all building backend services, we're all building JSON APIs, all the stuff that Go is expected to be used for. Cool. So nothing super surprising here, except for this thing. There should be two syntaxes you can use. One is the question mark, which is the kind of standard prepared query format, and the other one is $1, or the dollar indexing. The dollar indexing is super important for the Postgres driver, otherwise it fails, but not consistently. It only fails on types that have to be cast. And again, we couldn't really figure out why, but it is that way. And so after this, not very much code, it's about 100 lines total. This is the behavior we have. If we try and hit localhost, we know handler mounted, so we get 404, no big deal. If we try and hit foo, we get this nice error message because the cast failed. 1, 2, 3, we get the no widget ID again, which is 404. And we get ABC, well, again, totally standard. This is the thing you all need to remember. We're expecting 4, 5, 6 to work. And yeah, this is the interesting thing. Anyone using UUIDs for the database instead of normal primary keys? UUIDs? Yeah. Yeah? Nice, good call. This took me way too long to figure out, but when you insert into something with a primary key, it's pretty easy. You actually have insert, or exec, I think, and it actually gives you back in the result object the primary key of the thing which was inserted. And if you're using UUIDs, you can't. So you actually have to do this slightly strange query row, insert something, returning UUID. And that way you get back one row set, but if the insert fails, you still have to iterate over the rows, and the row set contains a bunch of errors, which is a really, really weird API. But apparently it has to be that way, and it's only that way for Postgres. MySQL's driver handles it much better. But this is how most of this will look when you insert new widgets and stuff, if you're using Postgres. Okay, these are the APIs for the database object, and you can see we have two types, DB and transaction, and they're basically the same. The only differences are commit and rollback, which, as you saw in the demos at the beginning of the talk, were to save the database transaction, try and save it anyway, or to throw everything away. These are the things that we care about. The other difference is begin, which gives us out of the DB and TX, but most people should be familiar with this kind of stuff. Of course, in Go, we're a bit closer to actually having to deal with the details. It's not like in Rails where you get some magic super global transaction pool. DB prepare. Why did I put that in there? I think that's not too important. Yeah, I remember why it's here. Sorry, strange thing. If you prepare a query on the DB driver, it stays in the DB driver, and that's fine. But if you prepare a query in the TX, at least at the time of writing, you can end up with some weird faults because this thing knows about the prepared query, the prepared statement, but it comes up with an invalid reference. So just be aware of that and try and avoid these things if you can at all. I think with the type safety of Go, prepared statements make a bit less sense than in other languages. But it really depends. I'm interested, again, show of hands. Anyone ever had a legitimate use for prepared statements? Nice.
Multiple execution of the same query with different data.
Yeah, sure. I mean, that's the common case, but I think in a web app context, it doesn't happen so much unless you prepare them all when the app comes up.
When you do bulk inserts via the API.
Yeah, that's a valid use case. Cool. So, having discussed, we know that transactions are probably better. We know that that allows us to stop things, to test things. We know that we need transactions so that we can, well, that's what the whole talk is about. So we're going to try and refactor this handler to use a transaction now. And the most obvious thing to do in the foo handler is to open the database connection as we were doing before, but we add these three things. And we're starting a transaction, we're deferring, committing it. Defer, everybody's fine with that, right? Good. In Hamburg, I got to the end of the talk and somebody asked me what the defer keyword meant, and I realized probably it was the wrong audience. And then we're querying the row on the transaction. Does anyone expect this to actually work and help solve our testing problem? No? There's a big problem with this. So we try it again. Anyway, we're running through the command line now, so testing. We don't have unit tests yet. And we have the exact same behavior as we had before. Everything works, we're now running the queries against a transaction, and we can pat ourselves on the back because it works and now it's transactional. And so we decide to write some tests for it, because we all, nobody writes tests first, right? Show of hands again, anyone never written a test in Go? You guys, just because it's a compiled language, you still have to write tests. All right, so the tests look exactly like the main application code. The Go test runner will replace your application's main function with the test runner main. And the test runner main uses the reflect package to enumerate all messages that start test and take a testing T type, and it will run them. And in case you want to fail the test, you call t.fatalf, and then it's failed. You can also log and do some other stuff. Sorry, somebody told me it's reading fatalf and it ruined reading code for me. Yeah, so we're writing a test. We're testing the success case. I mean, I have to say, honestly, I don't like using the standard library testing because it ends up super verbose and you end up with method names that are 200 characters long. And there's some other stuff, but I don't like those either. Anyway. Why? I don't know. It seems like half the people try to copy RSpec, which is probably the worst piece of software I can imagine. And the other half of people just focus more on formatting the output of your tests. And I would be a bit happier, I don't know, if there was some way to logically group the tests together. I guess I could do, for each suite of tests, you could make a struct type and define a load of testing methods on it, and then you could go like over your own test types and run your own tests. But I've never needed to do it, and I'm happy enough. Like all of the tests for Harrow are written in this style, and they're broken into individual packages. It's not super clean, but I need a really good reason to step outside of the standard library, and even though this looks like hell, it's still not bad enough to make me go looking for a third-party package. So running through the tests, so it's the first bit of code that might be unfamiliar. for some of you. We import two packages which are new here, testing and HTTP test. And HTTP test, we call this instead of HTTP server and handler. And the HTTP test will actually start a real HTTP server with just this one handler in it, in this case. And it will provide us, through this function call, a URL. And so you can be pretty much guaranteed it starts every time a random port. So internally it's mapped to port 0 and it relies on the kernel to give you a new port each time. And this TS URL only ever refers to this test. And like internally the test finishes, the test server is stopped, and everything gets cleaned up. So you can still run your tests in parallel, even though they're all listening on real TCP ports. I suppose there must be an upper limit somewhere where you run out of ports or something, but I didn't hit it yet. What next? So yeah, as I said, interesting thing is that the server only includes one handler. That can be a bit of a problem if you have authentication stuff. Sure.
Just a question. So you're using the actual handler, meaning you actually need a database for your tests to work. It's like an actual end-to-end test. What are you doing here?
Yeah, so the question was about whether it needs a real database. It does, and we'll come to why this is a bit of a problem in a minute. Now, if you remember a couple of slides ago, the handler function opens its own database connection, and so you can do that with some environmental variable, so it connects to a testing database or something. But yeah, that's a problem. So there's a big assumption here that there's a database running somewhere in the background. Sorry, excuse me. Yeah, okay, so then anyway, we run the test. Wait, where'd the test go? Oh, okay, yeah, so, and the test should work out. I'm missing a slide, sorry. Here's the question you asked. So I'm missing a slide that showed that test failing. Sorry, forgive me for that. And this is the extension of this code. That we're starting the server, we're deferring that the server should be shut down, fair enough. And then for this test, and this is the point though, so the original database includes one item with the ID 456. So when this test runs, it can actually find it. So that's okay, but that's not a very robust test. In case somebody clears the development database, the test would start failing. And so we have to extend the test to actually set up the environment that we expect. So again, with Rails or fixtures or Python, you have all of this stuff anyway. There isn't really a nice way to do testing fixtures in Go, not that I found anyway. I have to honestly say that my test database, my tests for Harold get kicked off by a makefile, and I dump into Postgres some fixture data that I expect. So some payment account, payment types, billing stuff, defaults that I expect. So I don't have to have all of that set up in Go code all the time. I'm not super thrilled about it, but it works pretty well. And I'm always a bit happier if there's a makefile in my project, even if it's a bit old school. And so anyway, we modified the test to include setting up the data we expect. So that's all everything that's highlighted in yellow, and you can see we're really getting into quite verbose, ugly code. And at this point, some of you may recognize we have for every test 2 connections to the database already, which isn't super bad because they get cleaned up really quickly, but Postgres has a really ridiculously small limit on the number of connections you can have open. It's about 50. You can increase it, but then you really kill the performance of the database, which is why a lot of people use PG Bouncer. So anyway, with this test modified, we run it with Go test. We're very happy that the tests compiled and ran in 32 milliseconds. No, that's 3.2 milliseconds. And then we run it again, because we're so proud of ourselves, and we run into the first real issue, which is me about 6 months ago when I started writing this stuff. Everybody understands why we're hitting this, right? I mean, we run the test inserted something into the database, we're running it again, and the test is blowing up because that thing is still there. And this is the point where we kind of regret choosing Go, and we wish this would be a Python application. Because now we have to learn a lot more about stuff than we ever wanted. And this is what the database looks like. No huge surprise here. So, transactions. We know transactions solve problems, and so we make the same modification to the test code as we made in the handler, but now the test code also uses a transaction. Anyone think this is going to fix the problem?
No.
Yeah, good. I did. when I wrote it. Yeah, we're running into exactly the same problem. We're starting a transaction, we're committing it way down here, and this leads to some interesting side effects. Everybody knows, I suppose, with a database transaction, if you're in the transaction, you can see the changes, and if you're not in the transaction, you can't. And that's actually the whole purpose of them, but it causes some problems. In this case, it works perfectly, where, yeah, you were right. And the reason is here, of course, that the transaction here, where we've inserted this thing, assume for the sake of argument that I actually cleaned up this mess here by hand. And then we're inserting one again, and it only exists on this transaction. And so although this record exists from here until here, and we're making the get here, the transaction isn't shared. And this, I have to say, this is one common problem I see with a lot of Go stuff, is that it's really, really difficult to share context. You've probably all run into it before, that if you have some middleware that takes a cookie and it finds a user, there's no kind of commonly accepted pattern of how you attach this user to the incoming request. I mean, there's like Gorilla Context and some other stuff, but none of them seem really elegant. I see a lot of people asking for Go routine local variables, which honestly is the worst thing I can imagine. But people seem really keen on solving that problem in a stupid way. So, same stuff, we get a 404, I just explained why. And we get even more fun stuff, because if we run the test again, we don't get the 404 anymore, we get the duplicate key value for the same reason that we did in the first place. Database is a mess. And so we reevaluate our place in the world, and we go back and scratch our heads. And we go back to the original handler and ask ourselves what we're doing wrong. And this is the original version, before we used the TX. Because obviously the little experiment about switching to transactions didn't work. And so what change should we make here? Well, we know we need a transaction. We need a database handle at least, but probably in here is the wrong place to be opening connections to the database anyway. If I wouldn't have ruined my mind with 5 years coding Rails, I probably would have figured that out sooner. So here's the problem code, and we have to pull all of this stuff out and put it into master, because whatever connection is being used, whatever handle to the database, be it a real handle or a transaction handle, we need to be in control of it. And we need to control that because in the tests, we need to specify that it's going to be start. Yes?
Just a quick question, because I don't remember. The DB object, is it thread safe?
Should be, yeah. I mean, it has some nice reconnect stuff. So internally, there's a pool of connections. It kind of guarantees that every Go routine should keep the same connection. So if you pass the DB into a Go routine, it should keep the same connection out of the pool. And it's a bit magic. I mean, we did some load testing on Harrow way back when. I think it was Go 1.2. And we were actually killing the database connection pool because the threads were staying around. The database connections were opening like crazy. Every time a new request came in, it was a new Go routine, it was a new connection in the database pool, and there was no way to control like clean out, timeout, expiry, and it was a bit of a mess. But now since Go 1.4, there's some functions you can call on the DB object which specify the pool size and the reconnect behavior, which makes life a bit easier. At least it means you don't have to run PG bouncer in dev mode, which is a bit easier. So, yeah, anyway, we need to be in control of this. And so we have to go back and we have to, and I'm sure most of us have been down this route before as well. We have this nice, convenient handle func. Oh, in the other half of this code, sorry, we had this convenient handle func, and we were just calling foo handler as a function. But it's time to kind of get past that now, and we have to make a foo handler type. It doesn't have to do very much, it just has to keep a reference to anything. In this case, we're only putting the transaction on there, but in the Harrow code, we actually have a bit more. We have like a handler type, which is embedded in all of our other types, and that handler includes some obvious stuff like the unique Nginx request ID, it includes the user, it includes some other references, and so we at least have a struct type that defines what we think a request looks like. It means we have to slightly mess with this convention here, but you'll see in the end of the presentation how that goes. I'm going to conduct a straw poll as well. Self for struct functions. Anyone agree with the naming or disagree? So let's see, who thinks that's a good way to name self? Bad way? Yeah, my bad. I have to say, I get kind of mad. I mean, I don't know what I should call this. FH, FS, FH.
That's usually what I do, just like the initials.
Yeah.
It's not more useful, it's just what people do. So
Yeah.
it's just so Python-y.
Yeah. Yeah. Oh, pretend that doesn't say self. Then at least you still respect me afterwards. Okay, so yeah, now the foo handler, we need an instance of the foo handler now. It's not just as easy as calling a function and relying on Go to set the stack up for us. We actually have to instantiate this thing and give it a transaction, which is starting to feel like real programming, starting to feel like we're professionals, so that's good. And we make the following change to main. So we pulled out the connection handling stuff to the database. We've moved it up into main. And when main starts, we're starting a transaction and deferring the commit. I'm happy to hear about anybody who thinks that's a terrible idea because it's a trap. And this now says handle rather than handle func, and we're passing a type in here rather than just passing the function. And so this transaction, in fact, I'm really curious. Anyone see the really stupid mistake?
You get every time the same transaction in the handler.
Yeah,
Because,
exactly.
The handler will be started in a Go routine, but not your main program.
Yeah, which is actually not that bad, except that from outside you don't see anything in the database until you quit the program.
Yes.
I made that mistake as well. So you
Yeah,
okay, cool.
especially if you scale out, that's going to be weird if you have two instances running.
Yeah, I mean, you know, I never coded Go before when I first went through this process, and so it's really funny looking at some of the crap that I wrote to come up with terrible example code for my presentation. So yeah, hopefully you avoid some of the mistakes I did. Okay, and we make the same change to the test, or at least a similar change. We already made the change to use a transaction. I don't recommend that you put the first 8 lines of code in every single test. I have a suite of test helpers in my code. I'm sure you guys will end up with that as well. One of which gives me a handle to the test database, and there's another wrapper around that which gives me a transaction on the test database. Interesting thing as well, and I think this is, I understand why it is the way it is, because defer is always run when the function returns, but it's so often the case that you have these defers for things which just seem unnecessary. I mean, it almost seems like if there would be another argument to defer, where you could specify which level of the call stack it got unwound at, would be kind of nice. And that way I could maybe, I don't know, like begin could give you a local transaction. You know, so it knows it's got to survive one function call, but it gets deferred one level higher. It's probably a terrible idea, but it would mean I had to write these two things way less, which would make me happy. Okay, anyway, corresponding changes. We're rolling back the transaction in the tests because we don't want to pollute our database again. And we're making the same change here. It's no longer handle func, it's foo handler with the transaction that we just made. And we're back to actually the happy path. We got through this in like 30 minutes so far. It only took me 3 weeks the first time. So, we discussed it already. Are we finished? No, no way. Because of this problem. And again, straw poll, this is an interactive session, apparently. Anyone have a nice pattern for this? Anyone have something that they do, some way of dealing with transactions and web stuff? No? Cool. Teaching.
Well, usually I write an interface reference to my database anyway, which is that more of a semantic access to the database, like not doing raw query and saying give me all posts or give me all widgets, stuff like that.
Yeah.
And I encapsulate all this kind of stuff in there.
Yeah, that's interesting. I actually, I tried something similar, like writing my own active record, not exactly active record, but more like a domain level thing. And in the end, I separated the objects from the database still. So I have a database wrapper, which represents an abstract storage class, and I have a storable interface, which is all of my domain models. And so the domain things themselves, they don't know anything about the database, and some of them end up in Redis, some of them end up in Postgres, some of them even on disk. And so I still have the same problems with the transaction, but at least I have a class which is responsible for worrying about that, so my HTTP code isn't polluted with all of this stuff. So, however, this is how it looks like towards the end, and this is where you start to realize, at least I started to realize, that probably it's time to go look for something outside the standard library, because this is starting to be a mess. You're all Gophers, so I assume that nobody has any questions about how this code is working. Cool. Better than Hamburg. Go Berlin. The one interesting thing, I had somebody in Hamburg ask me why I'm deferring the commit here. Isn't it safer to do it down here? And I was a bit confused because even I had to think about it for a minute, but actually it doesn't make a difference in the end. Because the transaction survives until we return up here, until we return here. So it's not too bad. And the final code, if anyone cares, is here. But that shouldn't make anyone happy. If, I don't know, maybe I set up a Google query, and if this code block ever shows up, I'm going to come and find whoever wrote it, copied it. It's terrible. Anyone happy? Who likes the code? I mean, I'll spare you. Let's take a look.
Have you an example also of this, the thing that you just said about the interface upon the database? It's kind of not active regular implementation, but kind of.
Yeah, it's not beautiful though.
I don't care if it's beautiful, just for curiosity. If you have, no?
Yeah, I can pull it up in a minute. Bear with me. So, all right, final status of all of this, and find it at GitHub and consider all the bad things they did and tell me about them. This is the final code, including tests. We have 70 plus 108 lines of code, which I have to say, from nothing except the standard library, is pretty nice. But it's also not very satisfying, because this stuff is kind of a mess here, and you don't want that everywhere. And this stuff way up here is also a horrible mess as well. And as I'm sure some of you know, there isn't really a winner for middleware stacks in Go yet, and there isn't really a winner for passing request context stuff around. If anyone's interested in that, you should take a look at some of these links. The first one, in fact, maybe these articles have both been on the top of Hacker News, so maybe you've seen them before. The first one is talking about 3 different ways to attach things to a request context. One uses a global map. The other one's using, you break the serve HTTP contract and you provide a third argument, which is the request context. I don't like that either. And the third one was a horrible idea, and I don't remember what it was, but that article is well worth a read. There's another library which isn't featured in here, but this is something that's come directly out of Google, which is the HTTP request context thing. Has anyone seen it? Yeah? Have you guys tried it?
I've been trying to use it, just can't get it to really like it.
Yeah, so just for some final information, then I try and take some questions and see if I can find some code for the gentleman at the back. It's not too ugly, the code that is. I mean, this is a really, really common pattern, that you have something that you need in here, be that a transaction, or be it a request token, or be it a WebSocket handler, it's something, something, something. And Google have a library for that, which includes a bunch of stuff which is super important for them. So they have this request context object, which includes like closure channels and everything else, so that when you query Google, and there internally they have timeouts, they have backend services, they have all of this stuff. The request context contains all the information about that, and any component with access to that context can send shutdown signals, and they get aware if the browser disconnects prematurely, and it's really, really cool. And I should find a link, and I'll fix my slides, and so in 10 minutes, if anyone looks at them on the internet, you find a link to that as well. All right. So we did questions and comments already, although I asked you more than you asked me, but if anyone has questions, go ahead. Meanwhile, I try and find some code. Any questions? Sorry.
Do you think that testing the capability to do transactions to the database via the web interface is really that good?
It's not about testing. I mean, we didn't, the application that we wrote did basically nothing, right? I mean, it just queried a row out of the database, but it's super important in case that you have, for example, one of the tests in the Harrow code base is testing what happens if you violate the primary key, if you violate the unique constraint on the email address field. And so when you sign up on Harrow, we create not just your user account, but some preferences tables and other stuff. And they get created by Postgres triggers because it's all belonging to the data model. Yeah, there's a good reason. I know that face. I made it as well, but there is a good reason. And so, yeah, what we were testing in that case was what happens when a user signs up and they violate the unique constraint on email, but we don't have leftover stuff in the database.
Yeah, okay, but when you're already relying on triggers and internal functions in Postgres, then you maybe want to include Postgres in that process.
Yeah, I mean, Postgres is included in that process, so our tests run against Postgres. But honestly, it's easier to unit test. Probably, I suppose it's an integration test, but it's easier to test your functions from Go via your own API than it is to try and write unit tests against Postgres, which I tried, and I will never speak about it.
When you use something like services, you could also mock the storage to something that is in memory. And
yeah, but if you're only testing the storage, I mean, I've been down that road with a MongoDB project where I wrote an in-memory version of MongoDB.
Ah, you wrote MongoDB.
Yeah. Yeah, and the in-memory version of that was pretty good, as long as you're only testing the down storage. But as soon as you rely on the database at all, it kind of falls down a bit, and then you're implementing stuff for the sake of testing it, so that you can test the implementation that you wrote.
Yeah, that's why you write something domain-specific layer around it, and you
I mean,
use that function stuff. Yeah,
it's a strange barrier, I know. Because I also didn't feel comfortable with MongoDB. The big problem I had was it was a Rails app, and I hate Rails, I hate MongoDB, and it wasn't the most fun project I ever had. But yeah, it was just so incredibly slow. Running the unit tests took like 30 seconds on top of the Rails startup time, and that was unacceptable. So for us, just to be able to work, we had to write our own backend, and then we ended up with more problems than we solved. Yeah. It's just the way it goes. I never had a problem with running tests directly against Postgres. We rely on it so much. I mean, for example, in Harrow, even our user welcome emails, the invitation mails you get, they're all based on triggers that are watching tables for new entries in Postgres. And we dispatch messages with listen and notify, and they go out over a tiny little bridge that listens to Postgres and puts them all in a message bus. Where we pick them up and we process them. So we use Postgres for absolutely everything, maybe to a fault sometimes. But, you know, all software sucks, you just get to choose which way your own sucks. So anyway, this is, that's way too small. Bear with me. Okay, the mic's still on. Cool, so this isn't beautiful code, but this is more or less the way. So, slightly sideways topic as well, the front end is based on Angular. We could have chosen between Angular and Ember, but we chose Angular because I like the idea that data is data and services are services. And so that also informed the design a bit here, where we have a store service, which knows how to take certain things. We have the data is separated, and these are interfaces. At least they should be interfaces. Bear with me, I should learn to use Vim. So we have this schedulable interface, which in Harrow is any job that you schedule, so like a recurring job, a cron job, or something that's scheduled one time, like tomorrow at 2 o'clock. And they both implement this schedulable interface. They have their own validations and stuff because they're all domain models. And they all go into here, which in some cases relies on the concrete type, because we always get a schedule out of the database. But they can be cast between the schedulable types in userland. So this is a slightly more realistic version of production code. And you see the only place we have a transaction is on the DB schedule store struct, which is always created with the new DB schedule store thing. And these storage things, if we have, for example, the jobs page, which shows you all of your jobs and everything else, the handler for that struct, the handler for that HTTP request includes references to each of the stores that are needed for that. But it's not super beautiful. It will be. We're probably open sourcing Haro sometime next year, although it's going to be paid as well. And so if anyone has improvements, then find us on GitHub sometime. But I don't know if that answers your question. I guess not, but come and find me. I'm around until the fireside chat. But anyway, so I guess we're done, right? Cool. Thank you, everyone, for listening.